Okay. Hello students. There was a network issue, so this one has been sent to you. Come fast. Fast. Suddenly video got stopped. Yes. Come fast. Okay. Until others will join, so I will explain it once again. So when I was talking about dichromate, we have already discussed that one of the important property of dichromate is it can act as a strong oxidizing agent. Right? Now, why it should act as a strong oxidizing agent? The answer will be one answer, or one of the reason will be central atom or element is in its highest oxidation state, that is chromium, right? So one of the reason can be due to the highest oxidation state of chromium, that is fine, plus 6, right, which is the highest for the chromium. But that is not the only answer, or that is not the only reason. There should be many other reasons why it should act as a strong oxidizing agent, especially under acidic condition. Right? So to understand this, we have to know the reaction. That is, if I take K2Cr2O7, that is potassium dichromate. So please remember, same logic is applicable for sodium dichromate also. Okay? Since we have prepared potassium dichromate, I am going with potassium dichromate only. Even same thing is applicable for sodium dichromate also. Under acidic condition, that is sulfuric acid. In the presence of sulfuric acid, now there will be a reaction. Where one of the product will be each metal sulfate. To be short, each metal sulfate will be the product. So which are those metals present here? Potassium and chromium. Right? So now one of the product will be potassium sulfate. So potassium sulfate, whether it is correct? No, because sulfate is -2. We require 2 potassium to neutralize the -2 charge of the sulfate. So that's where we have the potassium sulfate. Now another product will be chromium sulfate. So now I will tell that under acidic condition, whatever potassium, this one, chromium is there, from +6, it will become +3. Under acidic condition, please remember, chromium will reduce its oxidation number from +6 to +3. So that's where we have the condition, under acidic condition. That means here I am getting chromium sulfate. So chromium sulfate, what should be the formula then? Any one of you? I am giving a hint by telling that chromium from +6, it will become +3 under acidic condition. So that's where we have the oxidizing character, right? What do you mean by oxidizing agent? Oxidizing agents are those molecules or chemicals which will reduce themselves and it will oxidize the another molecule or other molecule, because it's like a balance. If one is getting oxidized, another one has to get reduced. So therefore we will call it as a redox reaction, because both will happen simultaneously, right? So now potassium dichromate is a oxidizing agent, right? So that means itself it should get reduced, then only it will oxidize the another molecule, right? So Purnima, no, Cr2O4, that is related to chromium oxide. Okay, So we are not talking about chromate or nothing like that. I told chromium sulfate. It's going to form the chromium sulfate. So the formula should be Cr2SO4 thrice. Right? Cr2SO4 thrice. So that's where we have the chromium sulfate. That's where we have the chromium sulfate. So don't get confused. Cr2SO4 thrice. If you observe it carefully, each sulfate minus 2, each chromium plus 3. Naturally, 3 2s are plus 6, 3 2s are minus 6. So net it will become 0. So that's where we have the chromium sulfate. Now another product will be water, which is required to balance the equation, because hydrogen is there on the left hand side, nothing is there on the right hand side. Now the important another product is formation of nascent oxygen. That's where we have the important molecule. There will be formation of nascent oxygen. Somewhere we have discussed about nascent oxygen. Where? Forgotten? Huh? Nascent oxygen. This is not the first time. So nascent oxygen is nothing but newly just formed. That's what nascent stands for. Nascent oxygen. That means atomic oxygen, which is formed during a reaction. They should be highly unstable. They cannot be stable molecule or element. So that's where we have the nascent oxygen. So we have discussed about this when we were talking about P block element, ozone. So during that time we have discussed about the nascent oxygen. Okay. So that's where we have the reaction. Now what is happening? Same type reaction you are going to observe in potassium permanganate under acidic condition. Please remember. Okay. So same type of or similar reaction you are going to observe in potassium permanganate also. So this reaction will be repeated. Only thing here is instead of potassium dichromate, there it will be potassium permanganate. Anyway, we will go to that one later. So that's where we have the reaction. Now based on the reaction we can tell that due to the liberation of nascent oxygen, potassium dichromate will act as a strong oxidizing agent under acidic condition. So what is that reason? The reason is due to the formation of nascent oxygen. Anyway, we have to balance it. So try to balance it off. Balance the equation. So 2 potassium, 2 potassium. Chromium is also 2. Okay. Now sulfur. Oh, sulfur is 4. But here it is only 1. So I will make it as 4. Because sulfur is on right hand side, it is 4. So 3 and 1, 4. So I will make it as 4 sulfuric acid. Now we will see whether it is balanced. So 4, 4, 16. 16 plus 7. It will be 22. 23. 16 plus 7 is 23. That means we have oxygen on left hand side 23. We'll observe on the right hand side. Okay, first hydrogen has to be balanced. Na? So 4 2s are 8. So here also I will make it as 4 water molecules. Okay. So now 4, 12 plus 4, then once again 4, then 1. So naturally it will be 21. So we will make it as 2 nascent oxygen, then it will become 23, right? All of you will agree? So once again we'll cross check. 2 potassium balanced, then chromium is 2 balanced, then hydrogen 4 2s are 8. So 4 2s are 8. Hydrogen is balanced. Now sulfur 4. So 1 plus 3, 4 balanced. Now we have to observe about the oxygen. So 4 4s are 16. 16 plus 7 it is 23 only, right? So yes, 23. So we will see how much it will be here. So 4 3s are 12. Another 4 oxygen. So another 4 oxygen and 1 oxygen was there. It will become 21. So what I have done is I have added another 2. Now it will become 23, right? Then it will become 3. We will see. So it will become 3. Nascent oxygen will become 3. Okay? Yes, now check Narasimha. Now I think it's correct. Okay? I had written 2O. Now I have made it as 3O. Nascent oxygen. So it will become 23. Yes. It will become 23. So that's where we have the reaction. All of you have understood? So there are two reasons for the oxidizing character. One is highest oxidation state of central atom, that is chromium. That is not the only reason. Under acidic condition, why they are strong oxidizing? That is due to the formation or liberation of nascent oxygen. And if you remember, same reason was there even for oxidizing character of ozone also. Same point was there with respect to oxidizing character of ozone. Fine? All of you have understood? So that's where we have the reaction. Fine? So any doubts? Any doubts? Fine? So we will go with one reaction to prove the oxidizing character of dichromate under acidic condition. Okay? So we will go with one of the reaction to prove that. See, for example, we have one of the molecule. Now what we are going to write? We are going to write the chemical reactions which proves the oxidizing nature of K2Cr2O7. So that's what we are going to discuss now to prove that one. Okay? So what is this? No, name of the molecule. I have written FeSO4. What should be the name of the molecule? It should be ferrous sulfate, because sulfate is with -2, right? Sulfate is with -2. Now ion should be +2. +2 form of ion will be ferrous with K2Cr2O7. Ferrous sulfate with K2Cr2O7. What can happen? Can anyone tell me? What should happen?
Same reactions.
Naturally, one of the product should be.
Yes, K2SO4.
Okay, I have not written sulfuric acid. Under acidic condition, I have to write sulfuric acid. So what should happen? Naturally, whatever product we have discussed with sulfuric acid, that will be there. So that is K2SO4, potassium sulfate, then chromium sulfate, right? Then chromium sulfate. Now you should tell me what should be other product. Potassium sulfate, chromium sulfate, yes, we have discussed with potassium dichromate and sulfuric acid reaction. Now what should be another product?
Ion chromate.
No. What should be another product? Now please remember, from +6 It has become plus 3.
Fe2O3.
No. Iron should get oxidized, definitely. Mayank has given partial answer. Ferric, that I agree, Fe2O3, where iron will be in ferric state, but Fe2O3 is not the product, that will be ferric sulfate. Fe2SO4 thrice. That will be ferric sulfate. Okay? So that's what we are going to get the product. Ferric sulfate. Now what is happening? It's a redox reaction where chromium plus 6 to plus 3, that means oxidizing character. Itself it is getting reduced. And iron from plus 2 to plus 3, that means itself it is getting oxidized. Itself it is getting oxidized, right? So ferrous sulfate is becoming ferric sulfate. So that shows the oxidizing character of potassium dichromate, and same thing should be applicable for sodium dichromate also. Fine. Now balance the equation first. We have to balance the equation. First metal, potassium 2, okay fine. So chromium 2, okay fine. Iron, okay, that's where we have the problem with iron. So there it is 2, here it is 1. For now I will make it as 2. We will see what will happen. Oh, H2O I have not written. H2O will be another product, otherwise you cannot balance, because hydrogen here, hydrogen is not there. Now I have written water. Now sulfur 2, 1, 3, but here it is 1, 4, then 3. Oh, 7 sulfur is there, here it has become only 2. Okay, so now instead of iron, first what I will do is I will go with the sulfur then. So I will make it as 7. 7 if I make it will be difficult, because iron cannot become 7, because here it is only 2. 7 will not work out, because if I make it 7, sulfur is fine. Okay, here it will become 8. So there it is 7. Now, so in that case, yes, 6 I will do. We will see. So 6 plus 1, 7. Now sulfur fine. Now iron became 6. So I will make it as 3. So 3. Now we have to see whether it is balanced. 2 potassium, 2 chromium. Now iron is 6. So iron is 6, sulfur 6 7. So okay, sulfur is not getting, it's got disturbed. Okay, we will try to go with this. Why to disturb iron? Sulfur is here now. 6, 1, 8. Here how much? Here 8 sulfur is there. Here how much is there? So 3 plus 1, 9. That means 13. Oh, 13. So if I want to make 13, so here I have to make 7, right? So I will make it as 7. So load or 13 sulfur. Okay, I think only thing water we have to balance. So 7 2s are 14. So here also 7 water molecules. Now oxygen automatically it has to be balanced. 7 24, 28 and 7. 59 oxygen. Now here 12 plus 4, 36, 7. I think it's balanced. Yeah, it's balanced. Okay, so there also it is 59, here also 59 oxygen. All of you have balanced. So that's where we have the balanced equation. You can go with balancing by using oxidation and reduction number also, no problem. Okay, redox reaction method also you can go, but in that case you should take ionic form. You should take the ionic form where Cr2O7 minus 2, Fe plus 2, SO4 minus 2 and H plus. So here also ionic form. That time also you can balance by telling that where chromium is getting converted from plus 6 to plus 3. So in that case, how many electron it has taken? It has taken 3 electrons, right? Same way, iron, how many electron it has donated? That means each ferrous sulfate will donate 1 electron. So that's where we have to balance now. Okay? So by using this redox method also, we can balance the equation, oxidation number method. Okay? So that's where we have the oxidizing character of potassium dichromate. Same way, this potassium dichromate, if it is treated with potassium iodide, what will happen? Potassium iodide is a colorless molecule. Okay? So what will happen? Potassium iodide, when treated with potassium dichromate, what will happen? It will get converted into brown colored molecule, that is iodine. So colorless solution will become brown color. Okay? So that's where we have the oxidizing character, -1 to 0. Same way, if I take hydrogen sulfide, what will happen? Potassium dichromate with hydrogen sulfide, what will happen? So hydrogen sulfide will get converted into sulfur, right? So from -1 to, so -2 to 0. Sulfide, hydrogen sulfide, please remember, when we are talking about sulfide, we are dealing with sulfur with -2 oxidation state. So from -2 to 0. So these are some of the example where oxidizing character of potassium dichromate can be observed. Once again, these reactions we are going to discuss in potassium permanganate also, chemical properties of potassium permanganate. All of you have understood? This is with respect to potassium dichromate. Any doubts? Any doubts? So shall we move to the next one? That is potassium permanganate. Shall we move to the next one? Okay. So with respect to potassium dichromate, what and all we have discussed? First we have discussed about preparation. Okay. Then we have discussed about reasons for the oxidizing character. Reasons for the oxidizing character of potassium dichromate. Then we have discussed about the reactions, especially one reaction in detail we have discussed. Reactions with respect to oxidizing character of potassium dichromate. Fine? Any doubts? So why potassium dichromate is a strong oxidizing agent under acidic condition? Due to the liberation of nascent oxygen. That's what your answer should be. Okay? Due to the liberation of nascent oxygen. Now we will move to the next one. That is potassium permanganate. Potassium permanganate. Okay? So what should be the molecular formula? KMnO4. This one you are going to use in your laboratory. Titration. Okay? So for titration they will ask this one. Potassium permanganate. KMnO4. Now you should tell me what is the oxidation number of manganese in potassium permanganate. So oxidation number calculation of manganese, right? So Mayank has already given the answer. Here it is plus 1 x minus 2. So nothing, no charge, so equal to 0. 4 into minus 2 plus x plus 1 because 1 potassium is there. So it will become 1 plus x minus 8 is equal to 0. How much you told? Yeah. So x 1 plus x is equal to 8. So x is equal to plus 7 because 8 minus 1 plus 7. Okay. So that's where we have the manganese is equal to plus 7. Okay. So that is with respect to potassium permanganate. Which is the highest oxidation number for manganese? It is plus 7. That means when I am talking about potassium permanganate, manganese is in its highest oxidation state. Manganese in its highest oxidation state. So that's where we have the potassium permanganate. We have another molecule, potassium manganate. Potassium manganate. So potassium manganate means K2MnO4. K2MnO4. So only one difference of potassium. KMnO4, K2MnO4. So what should be the oxidation state of manganese here? It should be plus 6. That means they are not in the same oxidation state. Please remember. There dichromate and chromate, it was same, but here oxidation number of manganese will be different with respect to manganate and permanganate. So in manganate it is plus 6, in permanganate it is plus 7. All of you will agree? Okay? Now when I am talking about manganese, what is the total valence electron in manganese? Anyone? Total valence electron in the sense outer shell. Including the subshell, you should tell me. That is argon. Argon 3d5, right? Argon 3d5 4s2, right? Now we can tell that since manganese plus 7, that means it will become 3d0 and 4s0 because all of them has been utilized. So whatever is left over, it is paired electrons. Leftover will be paired electrons. So that means it should become diamagnetic. It should become diamagnetic, right? So it should become diamagnetic. If I take potassium manganate, so where manganese plus 6, that means there should be presence of 3d1. Argon 3d1. So that means one unpaired electron is present. That means manganate should be paramagnetic. Manganate should be paramagnetic. So what I mean to tell here is, when I am talking about potassium manganate, all of you have understood this one, right? So whatever potassium permanganate is there, all of us we know that it is having black purple color. It is having black purple color or dark purple color. Dark purple color, which will be forming pinkish color solution with water, right? But when it comes to manganate, it will be having green color. It will be having green color. Please remember, if you go back to dichromate, orange red. Then chromate, it will be yellow. But if I take Cr plus 3, it will be once again green in color. All these things you remember for your competitive exams. Okay, they may ask, we don't know. Okay, so dichromate, when I am talking about dichromate, they are orange red color. Okay, so when I am talking about chromate, they are yellow color, but under acidic condition dichromate will get converted into Cr plus 3 form. So therefore, when I am talking about Cr plus 3, it will be green color. So these are the different colors of chromium ion under different oxidation state. Okay, so same logic when I am talking about potassium permanganate, where manganese is in +7 oxidation state, it will be dark purple or blackish purple color. But the same thing, manganese in potassium manganate, it will become greenish color. Okay, that is one thing. Next one here is, as I told, manganate, it will be paramagnetic. Manganate, it will be paramagnetic. And when it comes to permanganate, it will be diamagnetic. It will be diamagnetic. Okay? And naturally they will be having tetrahedral structure. They will be having tetrahedral structure. All of you have understood? Fine. So that's where we have the manganese with 4 oxygen. Right? With 4 oxygen. So in that, any of 3 can make the double bond. One will be with minus, which will be having interaction with the potassium. So that's where we have the potassium permanganate. 1, 2, 3, 4, 5, 6, 7. So potassium permanganate. Fine? All of you have understood? So when it comes to manganate, it will be Mn with once again 4 oxygen. But any of these 2 oxygen, among these, any of 2 will make the double bond. Okay? So therefore, it will be having potassium, potassium. Therefore, 1 electron will be there. So therefore, it will become paramagnetic. It will become paramagnetic. All of you have understood? But they are having, both of them are having tetrahedral structure. Both of them will have the tetrahedral structure. And one will be paramagnetic with green color, and another one will be dark or blackish purple color, which is diamagnetic. All of you have understood? Any doubts? This is related to potassium permanganate and manganate. Potassium manganate. Okay. Now we will come to very important one. That is preparation of KMNO4. Preparation of KMNO4. Okay, commercial preparation. It's there. Preparation of KMNO4. Okay. Now, it will be prepared by using pyrolusite mineral. It is a mineral. Pyrolusite means it will be having manganese oxide as its important component. Okay. So chromite ore with respect to potassium dichromate, and potassium permanganate, it will be pyrolusite, which is a mineral of manganese, which will be present as MnO2. Okay. Now, step 1. In case of the step 1, MnO2 will be treated with potassium hydroxide. So step 1 is reaction with potassium hydroxide. Reaction with potassium hydroxide. Okay. So now MnO2, okay, manganese oxide plus potassium hydroxide. Okay. In the presence of oxygen. In the presence of oxygen, the product will be K2MnO4, that is potassium manganate. Potassium manganate. So what is happening here? Manganese oxide, or you can write it as simply as pyrolusite, reacts with potassium hydroxide. Potassium hydroxide. So we have one of the product will be potassium manganate. What should be the another product? Potassium came, manganese came. Water, sorry, I only gave the answer. Hydrogen has not come. So another product should be water. Another product should be water. So balance the equation. First, balance it. Okay, manganese, yes. Okay, potassium is not balanced. So we'll make it as 2. So 2H2O. Oxygen will become, okay. So oxygen will not be balanced. So if I want to make oxygen to get balanced, then I should go with the next number, that is 4KOH. So 4, 2, 6, 2, 8. Here it is 4 and 1. Anyway, 4 KOH means here it should become 2H2O. Okay, there it is becoming 8, right? So here it is becoming 4 to 6. Okay, potassium has to increase now. So 4 to the 8 plus 2, 10. So okay, 2O2. Now whether it's balanced?
No, sir. Mn.
Oh, okay, okay. Manganese is there. So I will increase the manganese only. 2 to the 4. Okay, done. Now it is balanced. Fine. So that's where we have the reaction. First step. So first step is pyrolusite will be treated with potassium hydroxide in the presence of oxygen to give rise to potassium manganate. Whether final product we have got? No, we have not got the final product. Fine. Any doubts in this reaction? So shall we move to the next one? Okay. So next one is conversion of manganate. Conversion of manganate to permanganate. Step 2 is conversion of manganate to permanganate. That is treating of manganate. Treating of manganate with acid. Treating of manganate with acid or acidic condition. Exposing the manganate to acidic condition. Okay, so that means K2MnO4 in the presence of acid. In the presence of acid. So it will get converted into KMnO4. It will get converted into KMnO4 plus MnO2. It will get converted into KMnO4 and MnO2. Any other product has to be there? It should be water because H plus is there on the left hand side. So it should be water. Right? So that's where we have the potassium manganate. Potassium manganate under acidic condition, it will get converted into potassium permanganate, and here it will be, don't write it as pyrolusite, simply write it as manganese oxide. Okay, manganese oxide and water. Fine. So balance it. So 2 potassium, I will make it as 2 for time being, but it has to be changed because manganese will become 3. So what I will do is 2 K2MnO4 only I will take. So that manganese is balanced now. Now I have to increase the, okay, even that is not possible because we have the manganese over there. So that means potassium and manganese. Anyone of you have written?
That's not possible to balance.
That's what I'm thinking. Any product I have left. In textbook this reaction is not or we'll go with ionic equation. We will do with ionic equation, you can see. Because as a molecule it's not possible. Anyway, H plus is there, so we'll go with ionic equation. MnO4 minus 2. Okay. So we'll go with ionic equation. In that case, manganese from, okay, K2 minus 2 here. So here it should become minus 1. So manganese from plus 6, it is becoming plus 7. Okay. So that means plus 6 to plus 7. So here, the manganese oxide is also there. Both products are done. right? So plus 6 to plus 7. Okay. Mn4 minus 2. Mn4 minus plus 7 plus 6 means 1 electron is donating. We have to take 2H plus, which is becoming H2O. So each H plus is accepting 1 electron, that means 2 electrons. So that means 2 manganese should be there. MnO4 minus 2, right? So already on the, here also I'll make it as MnO4 minus 1. Still, manganese oxide is there, that is the problem.
Sir,
Hmm?
this reaction is
Hmm? Where it is?
it's sulfuric acid.
No, no. 2H plus general condition, if you take, it's not possible. If I take sulfuric acid, then manganese oxide will become manganese sulfate.
Manganese oxide plus potassium sulfate.
Minus 4. This charge of manganese. Here I will make it as 3. Similarly, 2 positive. Minus 6. Minus 2. So 3. 4. Yeah, that way I will do. Okay, fine. We will go with charge, neutralizing the charge, manganese 4H plus 2H2. Okay, done. This way we can do. All of you have understood? So here it is minus 1, minus 2. Okay. So 3 molecules of manganate with 4H plus, 2 molecules of permanganate ion, then manganese oxide and water. With sulfuric acid we have another reaction, we'll come to that. Fine? So that's where we have the 3 molecules I have taken. So in that way 3 and manganese will be balanced. So minus 2 net charge will be on the right hand side. Yes, it can be done. Because here it will be 2 plus charge will be left over. Because more and minus charge will be left over. Because 4 positive, 6 negative charge. So minus 2 here also, minus 2 here also. Then we can do. We can write it down, this equation. In textbook. Where I have kept, I don't know. Fine. This is where we have the reaction. You can write it down. This is correct now. So we have permanganate H plus, potassium permanganate. This is manganate and potassium permanganate, manganese oxide and water. This is one method, chemical method, where whatever manganate has been found, it will get converted into permanganate. This is a chemical method. We have another electrolytic method which we are going to discuss tomorrow, means Monday. That is the commercial one, but this is also one of the methods. Whatever manganate we have got, they will treat with the H plus to have the permanganate. Okay. So another method is electrolytic method, which we are going to discuss it on Monday. Any doubts? Because if you are going without ionic equation, this might be a bit difficult. We cannot balance the equation. So therefore I went with the ionic equation. Fine. So that's where we can balance the equation. If you take potassium manganate here, then it's very difficult to balance the equation. All of you have understood? Any doubt in this equation? All of you have understood? They are writing? Okay, Janami. Fine. So that's where we have the two-step process. What is that step 1? In step 1, pyrolusite, it will be treated with potassium hydroxide to have the manganate. Okay. So the next step is chemical method. If you are going with chemical method, this manganate will be exposed to acidic condition to get the permanganate. So this is one method. Now same way, same reaction, but second step will be different. Instead of chemical method, they will go with electrolytic method. Fine? Okay, anyway, I will stop here. In the tomorrow's class, means Monday's class, we are going to continue with the same. Okay? Thank you.